let's get a little practice in drawing chair structures. Of course, we know that the flat cyclohexane can give us some information, but it's oftentimes much more useful to look at the cyclohexane chair or ring sort of in a side-on manner. And the book in section 411 discusses drawing chairs. So Dr. Klein gives us a good step-by-step procedure, and he suggests drawing a wide V to start with, and then a line going downwards from the upper right of the wide V, not quite to the middle of your drawing. And now we start drawing parallel lines, because we have 3 different lines here. The next 3 are going to be parallel to one of these 3 lines. So the first one will parallel the first line we drew, and then the next one should parallel, and there we have a parallel. So it's a good idea to just practice these. Sometimes I fill my time in history or English when I'm bored by drawing chair structures. So the goal would be to have 3 sets of parallel lines. There is a set of parallel lines, and here's another set. And the final set I'll leave as non-bolded. And so let's get ourselves a nice chair structure here. And so what we're looking at this sort of from the end on, and you should think about, the side. And you should think about these 3 carbons as being closer to you than these 3 carbons. So these are further away, almost like we're looking at the side of a stop sign or the side of a disc. So once we have a good chair, let's go ahead and draw the axial hydrogens. So axial equals vertical. Whenever you're going to draw axial, you're going to draw 6 vertical lines, and there's always 6 axial positions on every chair structure, no matter what, if they're hydrogens, carbons, chlorines, whatever. So what we want to observe with these chair structures is, let me go up here, this one has 3 carbons that are oriented in what I call an up fashion. And then there are the other 3 carbons that are oriented in what I like to call a downward fashion. When we look at a carbon that's up, the axial position is straight up from that carbon. So these three carbons that are the up carbons in the cyclohexane chair all have axial hydrogens that are pointed straight up. And the opposite is true for the downward facing carbons. They have axial hydrogens that are pointed straight down. Not at an angle, not sort of half sideways, they're pointed straight down. And occasionally, as we see here, our hydrogens get a little bit obscured by some of the bonds in the cyclohexane. That's okay. That's not a problem. So let me erase this arrow. And then we're going to have 6 equatorial. And those are sort of horizontal. They're around the equator, as we might expect, around the sort of the belt of the chair. So there's going to be 6 of those. Each carbon has an equatorial hydrogen. And so the equatorial bonds will always be parallel to a carbon bond nearby. So let me draw the equatorial here. And you'll notice it's parallel to this bond, and it's parallel to this bond. And if we draw the equatorial for this top carbon here, it is parallel again to 2 of the bonds in the cyclohexane ring. So every equatorial bond should parallel 1 of the 3 sets of parallel bonds in your cyclohexane chair. The most difficult equatorial positions to draw are probably on these middle carbons here that I'll highlight with a dot. And so they will, again, parallel 2 of those carbon-carbon bonds. And then finally, over here on the left, so there's a cyclohexane chair with all 12 CH bonds drawn in their proper position. So let's practice that again without all my little smudge marks on the drawing. So let's get a nice new drawing here. A wide V, an angle down, parallel, parallel, and parallel. This is an up carbon, so it has an up axial and what we call a downward facing equatorial. This is a downward carbon. They alternate around the ring, so we have a downward axial and an upward facing equatorial. And you can see how the equatorial is upward facing because it's sort of just above a horizontal line. And this first equatorial that I drew is downward facing because it's just slightly pointed downward compared to a horizontal line. Going around the ring, here we have an up carbon, so we have an up axial, and we have a downward facing equatorial. Here's a downward carbon, so we have a down axial and an upward facing equatorial. Here's an up carbon, so we have up axial and a downward facing equatorial. And finally in the back we have a down axial and an upward facing equatorial. So the equatorial bonds should all parallel one of the sets of carbon-carbon bonds, and the axial bonds should always be perfectly vertical, whether they point downwards or upwards. They should always be perfectly vertical.